Hello everyone. Today I want us to talk about the while loop. So while loop is one of the most important loops, especially if you want to run things that infinite number of things, or you want a program to run infinite number of times, you can use a while loop. So while loop is very powerful. And in most cases, we are going to limit our while loop. So in most cases, we're going to start what we call a count. So we're going to have a count that is going to be initiated. So we can initiate a count. Then we say while not final count. Then what do? We do something. And then we increase the count. So that is basically what we'll be doing in while loop, while using a while loop. So we initiate some kind of a count. Not all the time do we do this, but this is if we are running, say, a finite number of things. Sometimes you may just start with while true mostly. So while true means the program will run until it's told to quit at some point. Okay. Actually, while true may run forever. So unless you initiate something and you say while true, and then you say at some point, you have to stop. So it will basically run the same way as this one. So we're going to do the same thing we did last time. So I'm going to start with some kind of a list with some, sorry. See. So let me just stop there. So we are going to call all these elements and print each at a time. So we're going to start with some kind of a count. I'm going to call it index equals to 0 because we usually start at index 0. So this is index 0, 1, 2, and 3. And then I'm going to say while index. You can use bracket less than, while index 0, 1, 2, 3, 4. While index less than 4, print. How do we call elements? L inside index. And then what do we do now? We increase the count. So we're going to say index plus equals 1. That means we're going to increase every time by 1. So the best way to do this is to call just the length of the list. Sometimes we have an infinite, a finite, a big number, like that is a big number of elements. So the best way is to call the length so that it does not inconvenience you at some point. So the length means up to the end, always, whether it's 10, whether it's a million. Okay. So you can see we following the same kind of format. This is what we are doing. So let's see what we have. Okay, so you can see we printed A, B, C, and D. So it will do the same even if we add something. That's the advantage of having the length, but not a specific number. So now you can see it will always go up to the end of the list, irrespective of the number of elements. So it's very, very easy actually. So the next thing that we did last week was to do some kind of a multiplication table. And we did a multiplication table for one thing. So we can do a multiplication table from what? So for instance, let's say that the one we did was for 1 to 10, all multiplied by 10, I think. So I'm going to say count equals to 1. So we started from 1. We can today start from 0. You can start from wherever you want. So I'm going to say while, we can use while count less than 11. So that means it will go up to 10. What do? We're going to print something. So we did some formatting. And the formatting was that x, small x, that equals to that. Okay, so this is count. So this will start from 0, 1, 2, blah, blah, blah. And this will always be 10, something multiplied by 10. Today you can do 9, multiplication table for 9. And then the solution is just going to be count times 9. Then there's something else we need to do is to increment count. So we're incrementing count by 1. And then there we have our multiplication table. Okay. So something else I want us to do is to find a sum of a list. So we're going to do something we call, we're going to create a list of Fibonacci sequence. I believe that is the spelling. So Fibonacci sequence, we're going to create a list of this form. So we have A1 or A0, whichever, A0, A1, A2, etc. So that is going to be the sequence, and the sequence is defined recursively as follows. So A0 equals to, many people define it differently. So you may start with 1, others start with 0. Let's start with 1. A1 equals 1. And A2 equals A0 plus A1. And in general, AN equals to A n minus 1 plus A n minus 2. So that's what we call a recursive formula. So we will add the at some point, we're going to write a function utilizing the recursive formula. But for now, let's do just normal normal appending to some kind of a list. Okay, so we're going to start with an list, empty list, which can also be started with something like that, but that is too much of work. Okay. So suppose we want to create the first 20 elements in the list. So we want 20 elements of the Fibonacci sequence. So we're going to count. Okay, so remember we're counting. So we say while count is less than 21. So because we want to do counting, counting what, 20 times. So we say if count equals 1. So we are going to append. So we're going to say fib.append. We can start by appending them, but let's just do appending all the time. We can just start by initiating the first 2 elements, and then, but we can do it this way. So when it's 1, we're going to say what? The first element is what? We can do up to 20 so that we can start from 0 to 19, but I want us to do from 1 to 20 to avoid confusion. So we're going to append 1. So we can also join if this is that, or count equals 2. Or we can say if count is less than something. So we can do a lot of things together, but let's try using these 2 so that you can see how to join. So or means that when count is 1 or when count is 2. If we used AND, it means when count is 1 and count is equals to 2, that is going to be impossible to obtain because count cannot be equal to 1 and 2 at the same time. So OR works very well here. And then we're going to append that. And then I'm going to say else. So what do we append? Oh, so we're going to append. So fib.append. So we're going to use that formula here. So we're going to call fib count minus 2 plus fib count. Sorry, I should use square brackets. Minus 1. Sorry. This, remember we are just calling previous element. So this is the previous element of the sequence. And this is the, I don't know how to call it, but the previous of the previous element. So that if we have something like, let me just stop it here. So that if we have 1 and 2, so I'm calling as if I'm calling the index. Yeah. I think that will be better because we are starting count at 1, count at 2. So we have count 1. So let's assume this is the indices. Let me just write something for index here so that we see what is going on here. So suppose I want the third one here. Now, after this, count is going to be so after this, count is going to be 3 at this point. And now I'm telling this to append fib count minus 2, that is 1, which is this one, and fib count minus 1, which is not there. So I'm going to get an error of index out of range. Let's try and run this and then see what will happen. But before that, I'm going to increase the count. So count plus equals 1. So the first thing I expect is an error. So let's see if we get the error. Exactly. So list index out of range. So you try and check and see if you can understand where the error is coming from, as I have explained. So the best way is to start the counting from 0. And then here we're going to end up at 19 because 0 to 19 is 20 items. And then here we can print something like the length. Length of the list means the number of elements in that list. So, sorry, what happened here now? Sorry, here is count is 0, 1. I think that works. Now you can see that works. And we have 20 elements. We can print the 20 elements and see if it follows the formula that we need. Yeah, so 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 2. So that is how we write the Fibonacci sequence. So that is the Fibonacci sequence. Now suppose we want to do the same and find the sum of the elements in the list. So finding the sum means we start here, add to this, add to this, add to this, add to this. So that means so we are going to have a count, and that count is not going to be more than the length. So we can have the count 0. So I'm just writing the skeleton. We can also say while not count equals, sorry, length, it's length of the list that we want. Do something and then increment the count by 1. Okay, so now to doing summation, we want to sum a list. So the best way to initialize a summation is by 0, because when you add anything to 0, it will not change. Like you add all this and you add a 0, it will not change. So that's why we initiate with 0 for summation and 1 for multiplication. Okay, so let's see what we do here now. So we're using count for as index. So let me just use index instead of count so that there's less confusion. So we're just using that for indexing. And then the next thing is to add, so result plus, sorry. So we are incrementing the result by an element in the index at hand. So like when index is 0, so result is 0, we're going to have result which is 0. We're going to add the first element. Fib 0 is the first element 1. So now the result is 1 and the index has moved to 1. Okay. So now we come back here, result is 1. Now that one we add the second element of the list, which is index 1, this. So we do the same way up to the last element of the list. So that is what we do. And the final result, we are not printing. If we print here, as I said, when you print inside the loop, you expect to get every result that comes up. So you're going to get like 20 results, which is not what we want. We want the final result, which will be printed outside of the loop. So let's see what we have. Sorry. Something happened here. Let me comment. Well, not print this. Okay, so let's see what happened because we're still getting a 0. That means something went wrong. So while not count equals not, I don't think that is the problem. Cannot be the problem. So we're incrementing the index. Result is being incremented here by fib index. Well, what happened then? So this is to mean that result here is not incrementing. So why is the result not incrementing? That seems okay. So okay. So let's see here before. Let's see what is happening here. So we're basically doing is called debugging. So let's print. So we are not even getting inside the loop. I don't know why. While not count equals no count index. Sorry, no, was index. So the problem was that. So we can now comment that and do this. So this is what we obtained summation. So we're going to end there for now. See you next time. Okay, thank you. Thank you.